terrific meeting, and he always, well, occasionally, since he is an engineer at MakerBot, sprinkle it with some secret MakerBot goodness. So definitely worth checking out. And then we have a new entry, Jenny's own 3D printing and hacking. This is a really different take on a meetup. It's for people that are interested in learning about 3D printing or just schmoozing about 3D printing. And Jenny has it in her apartment, and it's awesome. So
I have an update to that. We're moving to Pace, so we'll be able to hold 35 people, and we're going to have a solid 3D printer.
Okay.
And we're doing, I think we're going to do a hackathon in June.
Okay. There we go.
You said at the end of June?
Yeah, I think we're going to do a hackathon, I'm pretty sure. We're trying to get it organized, but at the beginning of June, we're going to have an open house at Pace.
Awesome. Okay. So, we have the main meeting coming up. We've already got that one scheduled. I apologize for our schedule being so late for April. But these are the tentatives. Alan and Hyman and his company, Make Simply, are pretty much a done deal. They're going to talk about getting your stuff out, you know, in production, sourcing, all that good stuff. Alan has a company that specializes in that, and he has a wealth of knowledge to share about that. We tentatively have a gentleman named Gordon LaPlante, who, not an engineer, but just decided one day I'm going to make my own 3D printer, design it from scratch, and he did, and it's going to be available for sale pretty soon, and it's kind of awesome. So we are going to have Kinesi, which is kind of an open source Raspberry Pi telemetry project. It's a locator project. It does a lot of very interesting things. Will be more details. And I think we might have maybe, I don't know, Robert, it might be June?
Might be June. Might be better. I can actually do a live demo in June.
Okay, so maybe we'll push that back to June. So keep June open then. It's a cool quadcopter for emergencies.
Emergency response.
Yeah. Awesome. Okay. All right, so some more biz. So, you know, we're always looking for presenters. It doesn't have to be anything it doesn't have to be chips and boards. It could be anything that is a tangible thing that you want to show off. Okay, this is a show and tell is what it is. I mean, it's cool if you're getting into production, but it's also cool if you're just making one for yourself. That's awesome too. And even if you haven't done anything yet and you're just on the drawing board, that can be a great presentation too. If you want feedback from the crowd, like, hey, what do you think about this thing that's on the drawing board? You want to present. Okay? And we're always looking for MakeIt NYC team members, so if anybody's interested in joining the team, come and see me.
What does that mean, to join the team?
Well, I mean, you do volunteer meetup-y kind of things, you know, wrangle presentations, keep on calling people incessantly to present, keep on reminding them that their slideshow is really, really late, you know, things like that. Okay, so last meeting I talked about this PCB SMT surface mount PCB class that we were going to do, presented by Hatham of New York Hardware Startup at the Zahn Center. And instructed by yours truly, and we had the class, and it went, I think, pretty well. We have
It's fantastic.
Okay, thank you. Great. I did not pay him to do that. Okay, and so you know, this is some of what came out of the class. We were making Arduino clones, and so this was just to give you some idea of scale. I have actually what I call the canonical class Arduino. Okay, so this is it. It's very small. Okay. And we had some people that stuck pretty much to the design, and we had other people, we handed out these cool trays to help sort parts. You can get an idea of how small some of these parts are. Parts over here like the size less than a grain of rice, very small. And this is someone pasting up their board that came back, and another board that's pasted up. Oops. And a really cool photo from one of our users, like, you know, in progress. Yes, everyone was wearing those. It was really geeky. This was from Jim Allen. He stuck pretty much to the plan, but he produced 3 clones, everyone perfectly functional and cool. Our own Jenny Cortina, this is her design. It's stuck pretty much similar to the example. This is a custom design from Victor Wang. Oops, oh, that's really unpleasant. This was from a gentleman named Jeff Urban. This is the most beautiful. He's never done this before, and he created a PCB work of art. It's beautiful. Yeah, it's lovely. Okay, no, he really did. I was just astonished and not a little jealous. Okay. All right, so in search of, does anybody need to find somebody? Anybody at all? No? Really? Wow. Okay, you're all set. Yep. Stand up. What you need?
I need sort of more of a business head. I'm more of a design head. And,
So you're, to what end?
product design. I'm trying to put together a business plan, and I'm trying to assemble a team to sort of figure out how these things go.
And your name is?
Theo Stewart Stan.
Okay, well, see.
And I can show you sort of the general ideas.
If you have some interest, see Theo. Do we have another ISO?
Well, not exactly, but I do have a question.
Okay, well,
I don't know
why don't we save the questions for later?
That's fine.
One more? No? Yeah? Stand up. Stand up.
I run a science and engineering education program for kids. I've been doing that for 10, 12 years. It's very successful. I'm now looking at opening up a physical space, sort of a hacker space, maker space kind of thing with a sort of family orientation. And I just need people who might be interested in helping with any aspect of teaching, developing, just helping in any way that you might be interested in.
And your name is?
My name is Laura.
Okay, so we'll do a reminder, but see, Laura, that sounds interesting. Anyone else?
I like to do a demo if possible today of a tech on chat I did.
Cannot do a demo today, but we could definitely schedule it for May.
Okay.
Not a problem. Okay, Mr. Clark, stand up.
Anyone here likes robots, likes things that fly, wants to be involved in flying robots at the same time? Just come see me after.
Okay, and Valentin, please.
I made the same announcement last time, but I'm a freelance engineer, and very often I'm swamped. And I am trying to make a small, tight network of people who are highly qualified in whatever they do, so I could give you an email, see if you could do this in a week or a weekend, and we'll all get paid.
Okay. What kind of engineer? Electrical?
I'm electrical,
Yeah.
electromechanical, but at this point, I'm just trying to get any expertise, technical expertise, that could do work fast and well.
Okay, cool.
Can you tell everybody to post it on the Meetup page or the contacts?
We could definitely do that. That's definitely a possibility.
We're here.
But we're here, and so everyone's going to stand up again at the end. We have time for one or two more. Patrick.
Hi everyone, I'm an independent inventor, not a very good one, but I am. And I have a project that requires a CAD file, so I'm looking for someone who understands SolidWorks. It's a very simple consumer item. So I'll be, if anyone is a designer knows how to do SolidWorks, I can describe what I'm looking for.
Cool. All the way to that.
My name is Dan. I come from Amphibian. We are a supply chain management and manufacturing operations company. We're out here looking for people making things. If you have any questions, you want to access the best practices around the globe, I'm more than welcome to talk to you, help you out, answer any questions you may have.
Okay, very good. All right, we're gonna move on. Megan, if you would step up, we're gonna have 5 minutes from Megan of Challenge Post. But in the meantime, Megan gave us these awesome T-shirts, and I'm going to do what I normally do and fling them into the audience. Does anyone want a blue large? Raise your hand.
Why not?
Okay. Does anyone want another blue large? Does anybody want a gray large? Gray large.
Wherever.
Oh, it's large.
And
What's your
we have
size?
a great extra large. Extra large?
Why are they all large?
Oh, okay. Perfect. That's it. We always try to have T-shirts. We'll try to have more next time. You wanna just kind of go back and forth.
So hey everyone, my name's Megan. I work for a company called Challenge Post. We run technology competition. So you might know of us because a couple months ago we ran New York's Next Top Makers with NYEDC. A couple of you participated in that. But I'm not here to talk to you about that today. I'm here to talk to you about a different challenge we're running. It's called the Ford Personalized Fuel Efficiency App Challenge. Before I get into the details of that, I just want to give you a little background on the technology behind that challenge, which is the Ford Motor Company's OpenXC platform. It's an open source hardware and software platform that basically is an API, an application programming interface to your car. So the idea is cars nowadays are like rolling computers without a monitor. You usually have to pay a mechanic several $100s to find out what's going on inside that dashboard of your car, and Ford is making it possible to actually plug in a hardware module and read that data yourself. The module takes the data, translates it into usable information, and then you can take that information and build apps with it. So right now it's compatible with Android apps, and then web apps, and mobile web apps.
What kind of cars?
So if you were to, I'll take questions at the end, I'll answer this one really quickly. Just look that up, because I knew that would be a question. You want to use the module and plug it into a car yourself. It does need to be a Ford vehicle. However, Ford has dummy data and sample data that's pulled from lots of other Ford vehicles, so even if you don't drive, or if you do drive and you don't have a Ford car, you can still use the data to build things. So anyway, as I said, we're running a challenge. It's called the Ford Personalized Fuel Efficiency App Challenge. But it is for hardware people too, because this is an open source Arduino project that just happens to have a software component built on top of it. So the task is to use the OpenXC platform to build vehicle-aware apps that talk to your car sensors and help drivers better understand their fuel economy. So Ford's doing this because they basically want to portray their company as a company that supports innovation, and they want to give drivers insight into their vehicles. So the rewards that they're giving out are $50,000 in cash prizes. That's broken down into about 6 different awards. I want to say the grand prize wins $25,000. The next one down from that is $15,000, so they're big cash prizes. And there's also a non-cash recognition award for large organizations. So if you work for this company and you'd like to enter on behalf of your org, you can certainly do that. You just won't be eligible for these cash prizes, recognition only. The important thing to note is that if you do enter this, you retain all IP. Ford does not take your app from you. They don't buy your app off of you. You retain the ownership. You retain the right to monetize that. So who should participate? A lot of you are probably thinking, we're hardware makers, we don't do software. Well, as I said, this is an open source hardware project, so for those of you who do play in hardware and are looking for an opportunity to get involved in software, I think this could be a really good segue from hardware to software. You get to work with both for this competition. So if you're an engineer, an inventor, or a software developer, this challenge would be for you. And unlike some of the other challenges we do, like Next Top Makers, for example, I know that was only open to residents of New York. This challenge is actually eligible to almost everyone. It's a worldwide challenge. You just can't live in or be a legal resident of Iran, Cuba, Sudan, North Korea, Syria. Basically any of those countries that we have sanctions with. So just to go over the basic requirements of this, these are pretty much it. There's a couple other questions you'll answer on the submission form, but you need a screenshot of your working app just so the judges can evaluate it, a video showing how it works, a link or a file where it can be accessed, and then my team actually tests all apps for quality assurance, so you'll need to provide us testing instructions. And this is the last slide. I'm wrapping things up. If you're interested in this, I'll be sticking around to answer questions. But first steps would be to go to forward.challengepost.com. ChallengePost is my company, and that's just a subdomain that Ford gets. The second step would be to sign up for a ChallengePost account. That way, you can take step 3 and register for the challenge, which means you're expressing interest in it, you've read through the eligibility requirements, you are expressing your intent to enter, and that way you'll get lots of important communications from us throughout the challenge, and we'll be able to follow up with you and see how progress is going. If you have questions, I can take a few now, or any excess I'll take at the end when I'm sticking around.
Yeah, actually it would be great if you could, if everyone could save the questions for the break and hit you up during the break, because we are running a little bit behind.
Yeah.
But thank you very much for and feel free to give us more t-shirts. We'll take them. Okay. All right. So we are going to start with Howard Fink in a moment. But before Howard starts, I just want to, especially given last month, I'm going to ask everyone to hold your questions for the end of the presentation. I'm going to ask everyone to be polite and kind to the presenters, because everyone here is coming out of a sense of community and sharing. Some people may be really good presenters, some people maybe not, but this is not about playing stump the presenter. This is about learning, from the presenter. So everyone be very nice and polite with your questions because they're all doing us a favor.
Turn off the phone.
Yes, and oh yeah, it would be good if we turn off the phones. That's another way of being polite, but thank you. Okay, so without any further delay, I present to you Howard Fink, Super Maker. This is Howard's second presentation, and this one is pretty darn cool. So Howard, big round of applause for Howard. To the right.
Thank you. When I was 10 years old, I got the Golden Book of the Stars and Planets, but I didn't really take up amateur astronomy until about year 2000 when I bought a telescope. And at the last opposition of Mars in 2003, when it was very large in the sky, I started taking pictures. This is a picture of the moon that I took in 2007. In 2009, NASA launched a Lunar Reconnaissance Orbiter. There had been a previous satellite, the Japanese Kaguya satellite, that was doing similar kinds of things, taking pictures, videos, and measuring the altitude of the surface. The NASA satellite was going to map the moon, the entire moon, at 10 meters resolution and selected areas at a half a meter. It's still in orbit. It's been 4 years. The data that it sends back to Earth is public. It's published on NASA's Planetary Data Center. And anyone can have access to it. Well, it launched in 2009, but it wasn't going to start returning data for almost a year. And in that interval, I wanted to learn how to use the data that it returned to make models of the lunar surface. And to do so, I needed some data. And when I started looking online, I discovered there wasn't much of any data. There was a German scientist who had done a paper on lunar domes. Finally, I was in communication with a NASA scientist who was doing imaging of Mars with the Mars orbiter, and he pointed me to this site, which is the U.S. Geological Survey's Astrogeology Center. And they had taken pictures in orbit around the moon during the Apollo 15 mission, taken stereo pairs, and converted that to a digital elevation model of the Apollo 15 landing site. Let's see, it's 1.8 gigs of data. And this is the manual. Basically, the data is a bunch of numbers in an array. The map scale tells you how far apart each of those values are. This is the whole piece of data. This is a photo of the site. So the data is in an equal rectangular projection. It's like Google Earth. That is, X's and Y's are equivalent to latitude and longitude. This is fairly close to the equator, and so the distortion is very low. And since this was my first pass at it, I decided to simply print X's and Y's and take the values that were in the array as the Z and simply make a print. Now, I use the software program called Mathematica, which is a computer algebra program. there's a function called relief plot. I read the data in, did a relief plot, which is a shaded relief view, and discovered that it was inverted. Okay, so I got it corrected, and when I was satisfied with the biggest problem that was that there was too much data, and so I had to go through this thing, thin it out, like pick every third value or every sixth value, until I got a file that the computer was capable of handling. This was the result. This is the Apollo 15 landing site. I made a bunch of them. And here's in this sample. You can pass it around, leave it at the back, on the back table when you're done. This was about December of 2009, early January. At about the same time, Paul Studis had discovered water on the North Pole of the Moon. He used an Indian satellite, got the data from that, and was able to determine how much water might be on the Moon, in the North Pole, in craters that were always in shadow. So in January of 2010, there was a conference, a one-day talk at the American Museum of Natural History. I brought one of these and gave it to him as a prize for discovering water on the Moon. And, so in 2010, here's the lunar orbiter data. This is 45 degrees south, and it is a bump map. That is, it goes from black to white. White is higher, black is lower. The value of the data of a single pixel here is the height in meters off of a reference radius. Now, I thought I had the manual, which was a text file that's associated with all the data files, has the same name. But it turns out there's a second manual for all of the data, and in it, it let me know that I didn't find out until afterwards that I was printing these things twice the height. That the difference in the height of the Moon is about 30,000 meters between the lowest and the highest value. You double that, you get 60,000. That fits nicely into a 16-bit number, which is 65,000. And so they printed them as a grayscale TIFF, and that's what you download to get the value. So here's the south pole of the Moon, 85 degrees south. And again, this is also twice the height. This is my first attempt at making a tiles. This is 14 inches on the side. And this is the north pole of the Moon, 80 degrees north. Now, a bump map is an array of numbers. So imagine like a tic-tac-toe board, 333, 363, 333. The 6 represents a bump. And when the software converts that into a surface, it's going to make a series of triangles. Now, each set of 3 numbers in each corner is going to be a triangle, and so it means that some of the points are shared. What you get are duplicate vertices. And what this does is essentially doubles the size of your file. It also may cause problems with the printer. So after you create the STL file in one program, you should move it into MeshLab, which is a tool for dealing with large meshes, and eliminate the duplicate vertices. And then this will reduce the file size. You can also convert from one 3D format to another. When I plot these surfaces, the Z numbers are the actual heights, and it could be 10,000 meters. But the adjacent pixels are 1 unit apart in the array, and so you'll get a file that's all scrunched together. And so you take it into MeshLab and you stretch it out so that each point is separated by the map scale. And this map. Now, this is 80 degrees south. In May of 2011, I was approached by Bill Stone. He asked me to make a movie landing on the moon on the South Pole. And I'd never used any animation software. Discovered Blender. Got one lesson. There was a Blender users group at the time. What I did is I brought in this file is 2,500 by 2,500. So there's 6.25 million vertices and 11 million faces. It was about 500 meg. You can't animate that. So I set up the sun. I actually cheated a little. It's a little higher than it really is. So I got a little more, I wanted to see a little more of the moon. Took a snapshot, then created a very low polygon version of the same area, and then painted this image onto that surface. And then I was able to make a movie. So you see there's still the 3D surface, but you get the high resolution from the original. Kind of jinked around, and this is Shackleton Crater. This is Mount Malapert. The mountain is important because it's visible from Earth, no matter what. The models in the back are the ones with 6 tiles were a test. Dr. Spudis wanted large models of the poles of the moon, and I promised I would make them. So we have a printer in which the bit is 10 inches by 15 inches. And so with 6 tiles, you get a 30-inch by 30-inch model. There's a hammer in the corner for scale. It took, one of these tiles is about 15 pounds, and that was too heavy. So the folks at the Advanced Media Studio at NYU looked into the software and discovered they could hollow it out. And they were doing learning as we went on. Some of the tiles shattered because the walls were too thin. But they got these things down to a couple of pounds apiece. Then they were infiltrated with cyanoacrylate to harden them up. They were double baked. The software measures from the bottom, and you don't know how deep a crater is, so I didn't bother calculating them. And I took them home and in my workshop put bases on them all and built them up so that they'd match. These are future projects. If you're doing this kind of work, You should pay really close attention to file names. You're going to be generating hundreds of files, believe me. And if you don't document your work or give yourself cues about what these things are, they're going to start digging into them and waste a lot of time. So here's Shackleton Crater again. For scale, this is about the size of New York City. You know, Manhattan, a little bit of the Bronx, Queens, and Brooklyn.
And we need to wrap, so I think
That's it.
all right. I will, if anyone has questions, raise your hand. I will point at you and ask Howard your question. Does anyone have a question for Howard about the lunar maps? Valentin?
Yes. So online, there's this crowdsourcing of mapping the lunar surface. So you could just register, and they'll give you an image, and you say that's a crater, that's a crater.
Moon Zoo.
Yeah.
Yeah, it's for doing a census of crater counts.
All right. Okay. Do you work with any of that data? Do you know where that data is going?
Well, it's going to the moon, the Galaxy Zoo group, but Moon Zoo is using data from the Lunar Reconnaissance Orbiter.
Same data. Okay. Thank you.
Anyone else?
What material do you print in?
It's this plaster-like material. It's
What's a 3D printer?
It's a Z-Corp printer.
Okay. Anyone else? No? Oh, one back.
Yeah. So I suppose the curvature is accurate?
Yes, you get a flat picture, okay? It's a stereographic projection at the poles. It's cylindrical around the equator. But the stereographic projection, you have to unproject to get you from x's and y's to latitude and longitude. It's still flat. So now you find the corner, the latitude of a corner, slice off the top of a sphere that's that size, and then add the dome to the data, and then you get the curvature.
You take my perfect sphere.
Yeah, the reference radius is 1,734 kilometers.
Okay. Any other questions? No? All right. Big hand for Howard. And feel free to check them out.
There's a YouTube site called Howard Fink H. That's the channel. And there's a bunch of moon movies there.
Awesome. Thank you, Howard. All right. I'm going to talk about something I'm working on. It's called the ModPeg. And I'll give you a minute to... Okay, so the ModPeg. I always like to start with a quote. I think that by the time we get to the end, you'll find that this is actually kind of funny. Okay, so the ModPeg, what the ModPeg started out as was a modular pegboard, plastic tiles snapped together, and you could use it as a pegboard, any size, any shape, colors, blah, blah, blah. And it kind of, you know, it came from the humble pegboard, you know? It came from the standard pegboard. But the standard pegboard has some problems. And that is, it's kind of ugly. And that's why you kind of find it in places like that. You know? It's not something you want in your kitchen or your living room, you just don't. And so I decided that, you know, I would design something that was a little more decorative and a little bit more consumer friendly. And, you know, this is a later prototype. I actually have a couple that I can pass around. Pass it around. So it's 3D printed, and one is what I call a display tile, one is actually a pegboard tile. So while I'm designing these things, and I think this is something that probably happens to a lot of inventors, or, you know, I thought, you know, there's all this space behind the tile, what could I do with that space? So I came up with the idea of using circuit boards that kind of interconnected to give you iterative circuits where some of the traces would actually be, where some of the traces would actually be exposed through what I call hotspots. I know they kind of look like something from health class in high school, but, and so actually this is one of the boards that I made. This is what's called a lighting and distribution board, because it takes 9 LEDs, but it also has these exposed hotspots that correspond to the pegboard, right? So, you know, this is audio left, this is audio right, this is I2C shared serial bus, this is DC, whatever, you know, and there are others, you know, and it's 4-way symmetrical, so no matter how you turn it, the spots are always in the same place. The idea being, you know, first you get this big grid. As you start to connect these things behind the tiles, you start to get this iterative grid, which you can kind of get a sense of what that's like. And the idea is that, you know, you'd be able to take things and plug it into a tile, and it would, you know, make a contact in the back, and it would go live, whatever that thing was. If it were a speaker, it would start playing music. You wouldn't have to do anything. So, oops, that is really, I think I need the bridge controller, man. Yeah. Oh, man. Okay, so, you know, that's like a very, very rough prototype of what a speaker would be like. If anyone wants to pass that around, it's just basically a speaker with two really the biggest pogo pins I could find. They're gigantic. They're like these mutant pogo pins. Love them. Okay, so this is what a ModPeg installation might look like. Okay, you know, I mean, that's like kind of an idea, and it would have different, you know, different add-on modules. Some of them might be tiles, some of them might be things that plug into tiles. And this is actually what's hanging on my wall now. This is actually a functional ModPeg. And it is backlit. And it gets, I mean, each one of those lighting tiles is probably equal to a 40-watt bulb that's behind 2mm opaque PLA. And it's really, really bright. And then you have the 8 display tiles. Now, the 8 display tiles are kind of interesting because I actually have one right here, and what they are is these are actually independent tiles. These are basically microcontrollers on their own. And do I have a dead battery? Yeah, so, you know, here's one right here, it's running off a battery. So you know, the display tile actually has its own microcontroller, has its own matrix controller, it's configurable, and I'm just gonna actually leave this up here because it's a little fragile. But the idea is that in order to get a display on there, there's actually right now, because of the auto exposure, there's actually an Arduino right here that's actually sending out distributed commands to each of the 8 tiles and keeping it all in sync. And each one of them is then displaying on its own 64 LED matrix. So it's like, this can get really, really, yeah, there's Arduino right there. So it can get really big, and it'll stay, yes? Oh, thank you. Okay, so let's move this along. All right, so that is it. Now, I can pass this around. This is actually one of the lighting boards. It's one of the lighting distribution boards that I created. Okay, so the thing is that I also, now there are some things that I have not shown because they're not really in a state to be shown, but, you know, I'm thinking to myself, what else would really go along with this? You know, like a charger for portable devices. And, you know, it's worth mentioning that Apple makes things really typical. There are no standards. Every phone needs a different variation of a charger. I mean, you know, you have an Apple 4 and Apple 5, 2 different connectors. You have Android phones, even those are problematic in terms of their connectors and their pinouts, and so you have to assume that every phone is different. Ultimately, the solution, I think, would be Bluetooth for audio. I actually do have a functioning Bluetooth module that allows you to stream audio through the grid, and a universal dock that basically requires someone to provide their own charging cable, and, you know, that way you don't have to deal with the royalties of the IP or anything along those lines. Okay. And then, you know, it's funny, a friend of mine actually a gentleman named Philip Mann, who's a good friend, said, "What? You know, this is all really great. What's it going to cost? What's it going to cost the end user?" And I have to confess that I really hadn't spent that much time working on an end user pricing model. And so I started to do it, and then I realized that there were some problems. So the plastics are easy. Probably $2. It could even be cheaper, because plastic is cheap. Even for like a 6-inch tile, plastic is pretty cheap. But then you start to get expensive. The lighting and distribution modules are maybe 10 to 15 bucks to the end consumer in relatively small volumes, like something that would be appropriate for a Kickstarter campaign. And, you know, it seems like a really, you know, low price when you compare it to an LED light bulb, which it effectively is. But I'll get back to that. And the smart modules, same thing, probably an end user price of 30 bucks a pop. And, you know, again, compared to an Arduino, it's cheap. It's an Arduino super set. It's got 64 LEDs, it's got connectors. And I really haven't done the math on the charger, Bluetooth speakers, anything like that. But, you know, the thing is, when you look at the pricing from a different perspective, that's when you start to see the problem, potentially. Okay, so just the plastic, the one that you just saw, 24 tiles, would be like 50. It would be 50 bucks, maybe 40 bucks. It really depends on what the volume is, but it would be relatively inexpensive. The bright wall, that is a wall that just got backlighting. Well, you know, once you add that in, you're talking about a 24 tile array. It's getting into 300 to 400 bucks, and that's a little expensive. And once you throw in the smart tiles, well, you know, you're over $500. I don't know if consumers are going to spend that kind. Sorry? Okay, so, you know, this is very relevant information. I'm just gonna, so I've come up with a few scenarios. Now, at some point, I'm going to turn this around and say, hey, what do you guys think? But I've come up with a few scenarios. The first one is just forget everything else and just get the plastics out. Okay, maybe that's a useful thing, maybe it's not. But you know, those are mostly done. The plastic design. The second one scenario is release the plastics with a backlight option. Now, if you're never going to release the smart tiles, you can actually bring down the price on the backlighting tremendously because you've got simpler connectors, you've got less, you know, you've got a simpler PCB. You could probably use ultimately actually cheaper LEDs. I use really nice, excellent LEDs, and they could probably use kind of somewhat crappy LEDs, and people will still be happy. And I could get it under $7. But you would never be able to do the distribution or anything like that, or at least it would be very cut down. And then the last possibility is to do, you know, well, I mean, you know, you get the cheap bright wall and that's it. That would be around $200 for 24. Now, suddenly that's a little more palatable. Or I could just finish everything that's that you've seen so far and just put it out there and see what happens. And I think that's probably not necessarily the best way to go. So that's it. That's the presentation. So now I'm going to turn it over to you. What do you guys think? I'd love to hear some feedback. So,
are there any issues, you know, like with regular pegboard equipment? Any problems with installing one of those and possibly breaking one of the electronic components?
No. It's totally pegboard compatible. Cool. Yes. We use I have a whole, you know, all my attachments just came from Grainger for the regular pegboard. They just plug in, no problem.
Could you feasibly get AC power to there?
I'm sorry?
Could you feasibly get AC, 120 volt AC?
Well, yeah, but then that's something that becomes an even higher bar because then UL jumps into place and all kinds of regulatory stuff. And then, you know, if you're burning down people's homes and no AC, and it's definitely going to stay below the voltage level for UL.
It seems to me that you're trying to make the decision. Let the customer make the decision. Why don't you put up on the website that these different components are available for sale? Maybe an application that allows the person to build theirs online first, and then it'll calculate how much that costs, and if they want it bad enough, they'll hit the buy button.
That could be a possibility.
I mean, you obviously have to have multiple numbers of each component in stock.
That's the issue.
Right, but as a starter project, you could just put 100 of each component in an inventory and then start seeing what the favorite configurations are. In fact, you could let the crowd sort of say, hey, look, this was my configuration, isn't that cool? This is my configuration, isn't that cool? And then let the consumers decide.
Can I install this in my apartment without losing my deposit?
Yes.
Yes.
It's like anything else you would hang on your wall. I mean, it's I mean, if you can make holes in your wall, or you can patch them on your way
Without
out.
making holes in my wall.
No, you gotta make holes in your wall. Sorry.
Could you mount it on a board and just hang the board? Or?
I guess that would be up to whoever buys it, but it's definitely, it's definitely meant to hold some weight, and so, yeah, so right now
So how many holes for each module would you have to put on the wall?
Oh, well, that's the thing. Once it's the final design, it should probably be no more than 4 to 8 holes around the perimeter.
And what's the dimension, the outer dimension?
The outer dimension of that was 24, that was 4 by 6, so that was 2 by 3 feet, a little more, the whole array that was shown.
You'll have to produce an injection mold.
Yes.
To produce the product.
Absolutely.
Multiple cavitation. You couldn't do as Patrick said, you couldn't really do a test and produce 100 of these things unless you did them by hand and you take the walls.
No, you would have to, ultimately, that's one of the issues is that
At least you have to build an aluminum tool with an inexpensive aluminum tool.
It's still thousands. You're gonna have to start out with
inventory.
Many thousands.
Your
Yeah.
minimum, no one's going to talk to you unless you do 1,000, 2,500 pieces.
Yeah, that sounds probably, it might even be a little higher than that.
Even higher than that. Well,
Yep.
you know,
I was thinking around 5,000 would probably be
you
good.
could get small quantities working with some local ones.
Okay. Another question over here?
What's your marketing plan for this?
I don't know.
To me, this is not something an individual should put on a website and sell one piecemeal. For me, it's go to a container store, go to all the people who are in the interior design business, go to the industrial people, and let them produce it.
That may be how it goes down, sure.
So is that, but you haven't figured, you haven't decided what yet?
Haven't decided what to do with it yet, any of it. With Mr. Clark?
Yes. How much stuff can I hang off of one of these?
How much stuff? Like, give me an example of what you want to do.
Like modules. So I've got this big pegboard on my wall, right? And now I just want to put stuff on it.
You could
hang what realistically put on there before it falls off the wall.
Whatever you would realistically put on a pegboard. I mean, if you had a pegboard in your living room, what would you put on that? I mean, it's meant to be a replacement. So,
So structurally, it's really a structural question in terms of load carrying capacity of the pegboard, whether or not it's
yes, because
equivalent or.
I think it's not an issue. How are we doing on time?
We've got room for one more question.
One more question.
You think it's a really good idea?
No, I don't know. Basically, that's why. Maybe it is, in fact, a problem looking for a solution. I mean, a solution looking for a problem. I may not actually be a useful thing. It may be something that I think is the bee's knees, but everyone else thinks is, yeah.
How do you use it at home?
I actually don't use it at home. That's just the demo. The next version, I actually will use at home. That one needs much improvement. All right, I just want to take one last question here.
Is it basically if you only do this in plastic, essentially what you're doing is you're replicating a pegboard, which at the end of the day is nice and clean. It's a nice, big, spacey area, nice and clean, very inexpensive. You're going to be infinitely more expensive by having little pieces of little puzzles that become a pegboard.
Well,
with lots of little horizontal and vertical zigzag lines.
I will say though, in the defense of the concept, it's what we may call very chauvinistically wife safe. This is something that theoretically you could hang it in the pantry and it wouldn't be a complete eyesore. Okay, whereas pegboard, you're not going to do that. So that's the idea, is to get the functionality of the pegboard, to make it so that people don't actually have to saw it to get it to size. That's the modular part of it. Make it so it's a little bit better looking. Maybe something that you might see in IT. All right. Well, thank you all very much. And, okay, and we are going to take a 15-minute break. So we will reconvene at 8.